Brilliant. Good morning, everyone. It's we've given a few minutes for everyone to join. Just wanted to say good morning and welcome to a webinar, our webinar around LHEES and heat network zoning. I am Torina Condradi. I'm a senior consultant at Ener-Vate, and we're joined by Jo Longden, our commercial director, who's most likely going to do most of the talking today. So I will leave it to her to introduce herself when we get to that part. As you understand, we are hosting this virtually, so I appreciate that hopefully we won't have any technical issues or anything like that will crop up. As you can imagine, I'm kind of sharing the screen, so I can't see all the attendees at the moment. So I can't see all everyone in the room. So just bear with us if there are any technical issues. The webinar is being recorded, so we can share it with attendees afterwards to refer back to. And we do encourage and I invite you to ask questions throughout the webinar, which we aim to address at the end. And we hope we've got too many questions to address at the end, which we will follow up via email. So I invite you to use the chat function to ask any questions. So before we kind of get started, the question is kind of, well, why are we hosting this webinar? Why have we invited you to join us, and why we hosting it? And it is because at the end of May, the Scottish Government published the heat network zoning guidance, which beautifully complements the work that's being done under LHEES, and it flows from the LHEES. But we also understand that it can sometimes, district heat networks can be a little bit overwhelming with all this technical phrases and technical terms. And we thought that by hosting this webinar, we can maybe take a little bit of that sting of the overwhelm out of it for you to go through what is required from you. Just bear with me. It looks like my PowerPoint has finished. Just bear with me. Just want to check, Jo, that so have I stopped sharing?
Yeah, it's gone off.
Okay. There we go, talking about technical challenges, and it happened within the first 3 minutes. Just bear with me one moment.
Okay.
Okay. Are we back?
Back on. Yeah.
Perfect. I'm just trying to see if I can't get back to the screen. Just bear with me.
It's on the home page. It's on the first page now, Trina.
Okay. It's like I haven't done this before almost. There we go.
That's it.
Perfect. So apologies for that, everyone, for the interruption there. As I was saying, kind of why we are delivering the webinar. So it's to kind of support you through the process of completing the pro forma. We've based the webinar on the pro forma and what's required from local authorities to complete as part of the process. So kind of helping you through that process on what information is required, things to consider, and potentially where you can find that information. So over to you, Jo, to do your introduction and get us started.
So good morning, everyone. Thank you for taking the time to join us today. I'm Jo Longden, Commercial Director of Ener-Vate. I'll come on to a little bit about what Ener-Vate do, but my role is supporting local authorities and private sector clients in developing of heat networks. And as Torina says, this webinar was born out of a bit of an idea I had, having spoken to a number of clients that have been tasked with completing the review and completing the pro forma and sort of share some of our knowledge. I've been developing heat networks now for about 15-20 years. So I thought I'd share some of the knowledge that may aid you as you go through that process. So yeah, nice to meet everybody. So do you want to jump straight into the slides now, Tarina? So, sorry, so Ener-Vate, it's gone too far.
Okay.
Go back. So Ener-Vate, as I mentioned, we work on around 40 projects at the moment around the UK, and we work on very early stage feasibility studies for district heat networks. We support clients for all the different stages, whether that be initial feasibility, all the way through to commercial modelings, investment board sign-offs, preparing documents for sign off with a certain your investment process. We work on commercial structuring and also then securing delivery partners to help deliver district heat networks. We also sit client side, and then after they've been built, to make sure they are actually built and are hitting the requirements that's been set at the very beginning. Quite often these things can get built, and then whoever managed it at the beginning is left, and it sort of gets left in a drawer, the contracts, but we brush them down and make sure that everything that you set out to achieve is being achieved. Okay. So there's just a few clients that we work for. As you'll see, there's a mix on there of public sector clients and private sector, all in the area of district heating, whether they've got projects in feasibility or actually some of these have got live projects that's actually constructed in the ground and delivering heat, particularly LHEES Pipes, which is a bit of a flagship project. If any of you've been to the ADE Awards, LHEES Pipes tends to win every award at the moment. It's a bit of a flagship. If you get 5 minutes, it's worth having a look up. It's a city centre district heat network which takes heat from an energy from waste plant, and they've been through some of the challenges that you guys will no doubt encounter when developing heat networks. We are arranging with Leeds City Council to do a visit and a bit of a Q&A with them on how they got through some of the different stages of developing that heat network. So again, I'll open that up to everybody who's attended today at some point later on. Thank you. So, as we just come back to the point that Trina made, you're all aware of LHEES, I'm sure, and you've probably been involved in the internal groups that's been set up to go through the different focus areas. Obviously, heat decarbonisation is the one we're going to be focusing on today, and particularly in the context of district heating and zoning. But appreciate that this is a fallout of a much wider LHEES strategy and delivery plan that you're all probably working on in different parts of your organisation. So just move on. So apologies if you do know. If you don't know, then I'll just run over it quickly. But a district heat network, a lot of people, when we mentioned that previously, I mean, it's getting a little bit more well known now, but I've been working in this, like I say, for about 15, 20 years now. And district heat networks have got some really bad reviews, some have got some black magic associated to it. It's like, how do you do it? It's quite simple. It is literally 2 big heating pipes under the ground, usually, preferably, and they're carrying hot water around the development or the site or the city. And it's used across some of the other countries, particularly Denmark, Copenhagen, Sweden, Finland. They're much more advanced than ourselves, but they are in those countries that I've just mentioned there. It's the norm to connect. So a bit like us with the gas network now, it's the norm to connect to district heat networks. But as I say, it is literally just two pipes carrying hot water around the city. What you do need is a source of generation, and what you do need is customers at the other end, and then the rest of it is just joining it up with pipe work. But we'll come on to a little bit more about that later on. So back to the pro forma that you're all tasked with completing. I'm sure you've had a chance to go through the guidance that was published on at the end of May, and then the pro forma is obviously there to be completed. It's made up of 3 parts. So the part A, which is the area review decision, part B, which is obviously the next stage along, which is the consultation and designation, and then part C is where everybody gets to a decision and says, yes, this is suitable for the construction and operation of a heat network. Now, when I looked at the pro forma in its format that is distributed in an Excel document, I thought, well, that looks quite simple. You just got to fill the boxes in. And the boxes make it look as if it's a very short piece of information that's required. And then I started thinking about, okay, so what are the considerations behind each one of those boxes? And that's where this webinar was born. So what I'm hoping to do today is take you through part A, which is all the different sections, a little bit on part B, and then part C is really the bit that you'll all get to at the end of your decision of, is this area suitable? So we'll go through part A now. So sorry, just before jumping into that, the part A obviously includes the assessment of the heat network, the opportunity areas, etc. Then we consult with stakeholders, then the zone designation. What I wanted to show on this slide is that's not where it stops, obviously. Once we get the area is designated as zone, then it's, okay, how do we take it through to the next stage of detailed commercialization? What delivery models are available? What's going to be available in terms of permit and consenting in that zone? And then we come into the whole world of design, build, operate. You might decide to give it to an energy partner. You might decide you want to do something in-house. You might decide to do JVs. There's lots and lots of different structures that could be adopted after that point. And then the very last box on there is EAMS, which is managing the asset. So as I mentioned previously, you've got this shiny district heat network that's been developed in your area. How do you make sure it's delivering against all the targets that you want to achieve as a local authority, particularly around fuel poverty and fairness, and making sure that the heat network operators don't just take the biggest loads and therefore don't deliver against some of the other targets you may require, which might not be the most commercially attractive to them. But so I just wanted to give them a bit of a full picture, but we're really focusing on the front end stuff. So on your pro forma, the first box is the your zone summary table. So your zone information and operations summary. And this is really a bit of a dropout of some of the information that you probably have done from your LHEES work. But this is just trying to capture your screening parameters. And there's a number of screening parameters that's been set for default. But I think one of the main messages I got from the guidance is, yes, there's default, but there's also variations that can be deemed to be accepted as well. Linear heat density. Now, linear heat density is obviously the calculation that is looking at the value of kilowatt hours per meter per year. And what that will do is create clusters, clusters of anchor load customers. So that's quite an academic piece of work that will say this building uses X amount, and there's 10 of those buildings in close proximity, therefore that must be suitable for a heat network. Now, as we'll come on to some of those considerations, that may not be the case. Clustering does put large numbers heat users together. It doesn't mean they're all suitable, but again, we'll come into that. So one of the things that I would think about when we're looking at the LHEES pure academic information is, how many of those are under the local authority control? How many can we actually commit to connect to a heat network? Are they on wet systems? Are they on suitable systems that may be able to connect to this heat network? I've worked on schemes where you've got new build customers and retrofit customers. So big, large heritage buildings that's chugging through some gas boilers at the moment on high temperature, 80-yard design. You would think initially they're not suitable for district heating, but they can be. And LHEES Pipes is a perfect example of where you've got new build and retrofit customers on that network. But again, certain considerations need to be made in the design of the heat network and some of the generation sources. And also some of these buildings will have heritage status, which means you can't run pipes where you might want to run pipes to get to a plant room. And again, they can put them in the difficult to connect bracket. But it's good to just have an awareness of that's where the heat load is. These have got 20 customers and this is the heat density. However, some of these other considerations will need to be taken into account when you start getting into your engagement and consultation with some of those building owners. If they're under local authority control, that information can be a bit easier to obtain. If they're not, then obviously it means engaging with private entities. This buffer radius, so the default has been set at 250 metres. I have a bit of a view on buffer radiuses for lots of reasons, and it comes with my hat of developing district heat networks. Is the minute you put a fine line that says that's your end of your line, then loads could be missed because they're just over that. They're just over that buffer, and therefore the shape of the zone should actually be able to change. But some of those considerations need to be made, and we'll come on to how you look at the buffer radius later on. But it's particularly around where you've got clusters of heat or planned heat, new build developments, large social housing retrofit, whatever it may be, just outside of those buffer zones. So it's really key to try and think holistically about what may happen. And like I say, it's been set default of 250 meters, but again, you can change that. So if you think something's coming over the horizon in 5-10 years, you can increase that buffer radius. You just need to have a bit of a justification for it. Next slide, please. Okay, so this is the bit that we've got all these customers. We know where the heat is. Always city centres quite tight together. And then the next question is, where do we get the heat from? So as I mentioned, pipes are the easy bit, really. It's where do we get the heat from? Now, typically, when I started in district heating, this was gas CHP engines. Well, they're a big no now. So then we've moved more towards the heat pump market. So we've got your low carbon networks, which are running on heat pumps, which are taking heat from water sources like the River Clyde. You've got air source heat pumps, which can have a centralized number of plant. Ground source heat pumps, we can drill down, extract from underneath the earth. You can go into aquifers, which is sort of low level water. They are what I class as the new technologies. In addition to that, we've got lots of other sources that can be explored and are being explored now that weren't being explored 5 years ago. And they include like energy from waste plants. So example there's a consented energy from waste plant on South Clyde, Fortum plant. We're considering a district heat network off the back of that. If you've got an energy from waste plant, then you've usually got a source of low carbon, low cost heat. And LHEES pipes is, again, I know I've referred to it already, great example of an energy from waste plant that's on the periphery of the city, bringing heat into the city and decarbonising that. So there's lots of other things now we're looking at. Process heat, so data centres, large manufacturers. These can be a little bit more challenging. Now, at this stage for the pro forma, you've really just got to identify them and have an understanding if they've a possibility to extract that heat. When you get into feasibility, you start getting into much more detail about where that heat comes from and at what temperatures. But it's good to have an understanding of what that might be, because you could identify a glass processing plant. I'll give you an example. And you think, oh, that's fantastic, that's going to be my heat source. Well, that glass processing plant might only operate at certain hours a day, on certain days of the year, at certain temperatures that's not useful for delivery of heat. So whilst you might think you've got a fantastic opportunity, it might not be as usable as you think. So you wouldn't want to then use that as your main focus for that area or that zone. So I've listed here a few considerations, and we will circulate these, but feel free to ask any questions. But these are the sort of things I would go through if I was talking to a heat generator. When is it available? What temperature can you give me? Whereabouts are you in location to proximity to my end customers? How easy can it be captured? Is it going to cost an absolute fortune to do the capture? Where will I put my energy centre? Is there some land close by that I might be able to utilise? And also, people want paying for heat. So how much is that heat going to cost me? And if it's going to be economic enough to be then sold on, which will still give a saving, particularly in the areas that we're focusing on fuel poverty. And then there's the risk on supply, which that comes back more to when will it be available and who's going to guarantee that heat factory, if you like, will be there for 5-10 years. Some of the best heat networks I've seen, and this is the way that it's done in other countries, is where they have multiple heat technologies, and that gives you the balance on risk and supply. So the more heat generation opportunities you've got in a zone gives you more opportunity then when it goes to market to give comfort that there'll be enough heat generation opportunity to fulfill the requirements. So section 3 on your pro forma, identify key thermal loads. So how real are the loads? So as we mentioned, the LHEES, some of that has been done in quite an academic way. Some of it's on real data, perfect. Some of it's done on estimated data or legacy data. What you typically find is when you start talking to customers and engaging in detail, everything's changed. It could even change since pre-COVID, post-COVID, if you look at occupancy of buildings. But you've also got things like how long is that building going to be there? If it's a school, is it being knocked down in 5 years because there's plans to do a wider academy? Is it being expanded because there's a high density of new build residential and the schools need to be made bigger or even built new ones? And then also, what is the distribution like in some of those buildings? So we might look on a piece of paper and say there's a huge building there, but actually when you get into the design of that building's been designed on a system that is not suitable for the wet system. It could have air handling units or different variations, or in some cases, particularly with blocks of housing, it can be on an all electric system, in which case there's no wet system in the building at all. And then we'll come on to how you can deal with that later on. But sometimes that means that the wet systems themselves, we might be assuming they're a great anchor load, but they may not be suitable for connection. Thinking about buildings that's got gas boilers in at the moment, the ideal time to connect buildings is when they're getting to the end of their life. They don't want to have this brand new shiny boiler they've just bought and then somebody says you must connect to a heat network. So again, we're just trying to think about the program of some of those replacements for those gas boilers and how those they make a natural change into connecting to the district heating. One big positive I will say though for district heating, and this is why it does lend itself well to retrofit, is it's quite an easy change. So if you look at a gas boiler in a plant room, you take out the gas boiler and you can put a plate heat exchanger in its place, and then you can connect back up to a secondary system, which is a wet system. So when you consider that compared to an individual air source or an individual ground source or something else, it's much easier to retrofit district heating into that scenario for the reasons I've just said, because it's still a wet system ultimately. Yep, I think that's enough on that slide. So number 4, existing infrastructure considerations. So there's not a huge amount of heat networks in Scotland. The Midlothian one, which obviously we'll come on to, and the Queen's Quay, which we know about. But is there any existing networks? And if the answer is not yet, is there any planned? So, for example, I've just shown the drawing there. That's the Glasgow Harbour scheme that we work on. Glasgow Waters, as it's now known. That's a waterfront scheme. It's a peel project, taking heat from the river and distributing it around in the same method we just talked about as hot water. That scheme there is about to go into planning and will be operational by end of 24, early 25. So being aware of these projects can help when you're thinking about zoning. If there's something in your area that's being developed or at least spoken about at this sort of level, so it's sort of guaranteed to be happening, is there networks that you might be able to extend? Is there university networks that, all right, might be on gas but need to be decarbonised, but is there an opportunity to do that within a zone? If there's one already there, like the Queen's Quay one, perfect example, does it have the capacity to be expanded? It's low carbon already. Does it have any future plans to be even zero carbon, for example? All of those are questions which will help, because if there's an existing network, you're already got a bit of a first mover advantage, because it's sometimes easier to extend out an existing network than it is to start from scratch from the detailed feasibility. So there's a consideration. Grid locations, substations. Now, this is a key one if you're looking at brand new networks. And the reason being is all of the technologies I've mentioned, heat pump wise, require electricity connection. So if you were to put in 100 heat pumps, that's a massive draw on electricity. What you tend to find with heat networks is you put in a large heat network in, and then you've got a diversity of network. So you actually reduce your capacity demand down by 2/3. So that centralised heat pumps will reduce it down by 2/3. However, there's still a demand for electricity. So if you're developing this wonderful heat network, but you're really starved of capacity, you might want to think about strategically where you can place that energy centre, where you might be able to access some of that capacity. And again, bridges and roads. So bridges and roads, Absolutely fine. No issue with any bridges or roads. But you do need to consider the infrastructure that's currently in place and where those main pipes may need to run and how easy it is to close off certain roads, in particularly roads where you've got your main arterial routes into your city centre. It can be done. Leeds have done it, Liverpool, Manchester, but it's just a consideration to take into account. Good to engage with the highways team at this point to understand what's planned in terms of resurfacing. If you can get in at the same time or something's planned for the early next few years, try to line programs. We've done that in Liverpool. We've put pipe in new roads, even though there's no energy centre built yet. But again, it's just a case of then you don't want to be digging up the same roads twice. And bridges or crossings required to enable this. So bridges can work perfectly to help us out if they've got the depth within them. If they haven't, you can do pipe bridges, and we'll come on to a picture of what that pipe bridge might look like later on. But there are just considerations when you're looking at existing infrastructure. So the pro forma asked to capture some information around fuel poverty. And obviously, I'm sure you're working within your teams and your housing teams to fill that in. So when you look at the pro forma, it's really a bit of a count as opposed to anything else around the fuel poverty numbers. But what I want to talk today about is fuel poverty is it can be clusters of areas. So the picture you can see there is some blocks of apartments in Leeds. They were on all electric, and they've actually now gone through a major refurb, and they are connected to the district heat network. Blocks of apartments, sheltered accommodation, care homes, anything that's got a centralised plant room can be connected relatively easily. Anything that's got an individual boiler or an individual supply is a little bit more challenging. So something just to think about when you're looking at where your areas of fuel poverty are and how you might address them. Blocks and centralised systems are easier for now. The solutions for individual retrofit properties will come later on, a little bit later down the line. It's fair to say not all dwellings are suitable for heat networks without upgrade. So again, aligning programs and speaking with housing colleagues around or housing associations in your area around what are their plans for retrofitting insulation, so basically fabric, and would they consider putting wet systems into apartments that have got all electric. And I'll give you a good example. And there was a story told at the ADE in Leeds a couple of months back about, and it came from a tenant liaison officer actually, about a lady who lived in one of these flats here. And she was on all electric system, and she was really, really struggling. She couldn't afford. She was one of those choose between heat and eat, so, and terrible time. And she actually gave a statement that said that this has changed her life by being connected to a district heat network because the running costs were 2/3 lower than an all electric apartment, and she now didn't need to make that choice. And you know, as a district heating developer sitting in that room, that's what we do it for. But so this is where it can have a huge impact if we get this right on taking district heat to the right areas and focusing it on connecting those customers that really need it the most. That's enough on that slide, please. So point 6 on your pro forma is your local development plan. And I think it just says is the zone within 250 metres of an LDP site. That's probably a bit of an easy one to answer with your planning team. But some of the things that we like to consider for the new build is if the site's being built forward by the council or a local housing association, that's great. But if not, who's bringing it forward? Who owns the land? What's planned for the land? Is it residential? Is it commercial? Is it individual houses? Needs a separate thought process. Is it blocks of apartments or student? Again, we just need to be thinking what is going to be planned there, because that will dictate how viable that network becomes. If it's 1,000 residential, it's quite easy to work out what the load would be for that, or make some assumptions around some of the commercial buildings. Another consideration for those areas is, does it have spare land? Would it be welcome to have an energy centre on that land? So typically of past, nobody's wanted an energy centre next to residential because people deem it as not attractive. But now what you're starting to see is we've got some fantastic architects now in the UK integrating designs of energy centres into large new developments. So you can clad them, you can build them in basements of car parks, you can do all sorts of things, but it's worth considering at this stage, is there space for an energy centre? And also, it's okay being 250 metres away from an LDP site, but what's the programme? Will they need heat before this district heating can get there? How will we not miss out on some of those loads? So understanding the programme for any of those developments is key. And that should help them make the decision of, yes, it's close to an LDP, but actually that's not planned for another 15 years, or we're actually on site and we've missed something. And any other large new build developments that should be taken into consideration should be filled into this element on the pro forma, because you might have, I mean, I've got you the picture there, that's Therme, that's the large leisure facility that's planned down in Glasgow on the waterfront. You might have large developments that's outside of an LDP, but you want to consider those as well. So again, just trying to think about some of the new build activity that may or may not be happening in those areas. Okay. Constraints. Okay, so when I looked at the Excel document for constraints, and it just lists a number of constraints, and I thought this is the bit that can be quite challenging to have a bit of a think about. It lists down what the major roads are they present, usually in a city centre, and some of the other things around conservation areas. This is the one that can make a project viable or unviable when you start going out to market. And the reason I say that is because anything, pretty much, except railway lines, pretty much anything can be overcome in terms of installing network pipe. The challenges come is the harder it is, the more expensive it is. And therefore, when you're going out to market to talk to energy companies, the attractiveness of some of those heat nets will be depend on that commercial aspect of how much is it going to cost me to deliver this network. So just thinking when you're back to your designation point of where's the ideal for a zone, I just wanted to run through some of the ones that's mentioned. So your main highways into your cities, we all have issues with congestion as it is, but they're the roads that you're going to be probably needing to go in or under. In Liverpool, for example, we needed to cross a main route into the city centre. It was already heavily congested with other services. So we tunnelled down 6 metres underneath the road, and we had a man boring through to create the space for the pipes, and we installed some huge district heating pipes under that route. It can be done, but it was very expensive. But sometimes that's your only option. Railway bridges, sometimes you can go under, but just bear in mind when you think about railway bridges, anything to do with railway adds complexity, because just more around the easements and being allowed to put pipe work. A lot of the railway operators struggle with the context of that. Water bridges, easily we can go in bridges, we can go across bridges, but again, it's not your standard installation, so it adds extra complexity and cost. Land which requires special treatment remediation. So it talked about peat in the guidance, but there's also lots of other scenarios where because you're digging down to lay pipes, and because all of the land is old and had many, many uses over the time, quite often it needs remediation. Now, some of that is relatively cost-free. Some of that can be really expensive, particularly if you've got areas of buried asbestos and concrete. And around docklands areas and any port areas, there's always lots of buried activities over the years. So again, probably just want to consider, if you've got known areas, then think about that when you're looking at your designation of zones, because that could make it less attractive to the market if they've got to do a huge amount of remediation to the land before they can actually put pipe in the ground. Third-party landowners, sometimes that has caused challenges in the past. People don't want them to cross their land with pipes, but sometimes it's necessary. Again, this will come into the consultation period of why it's necessary and for the greater good, but it can sometimes slow down the delivery of a heat network. Protected land, same really ilk as that. Railway lines, they are a no-no. So if you have a railway line, avoid at all costs, because it's very, very difficult to go under. You can go over if you can get the railway company on side. Nobody really likes hot water pipes going over a railway either. So railway lines, having said most constraints can be overcome, which they can, railway lines is the one that I would say avoid if possible. Okay. So the next slide, Trina, please. So this is just a couple of images. So the one on the left is the one I mentioned. They're the big DN400 district heat network pipes. So just to give you a bit of context of size, they're real life size men stood next to them, as you can see in that hole. And that hole, that hole is 600 meter, 6 meters. Sorry, not 600, 6 meters down going under the roads in Liverpool. So I just wanted to show you that because just to put a bit of context to me waffling on, they are the huge DN400s. Now, in the UK, DN400s have been typically the largest pipes that we've installed. But what we are seeing now is a requirement for much bigger pipes than that for your main transmission lines on some of the larger zones. So where you've got particularly around sort of Greater Manchester, for example, where they're looking at how they can decarbonise Greater Manchester, we're talking about pipes that are in the region of sort of DN 1200, 1400. So you can imagine 3 times the size of those ones you can see on the screen. Now, that's a whole new world, and that comes with other complexities when you're starting to excavate for those pipes. But I just wanted to show those 2 photos just to give you a bit of context on the size of those pipes. So they are your points for your part A. So they're on your spreadsheet, and that should be pretty much it in terms of some of the considerations. Now, I could probably talk all day around and go into much more detail on all of them, but you probably won't want that long webinar. But that should give a bit of an overview to some of the considerations that I see for part A to help aid your pro forma. So part B is obviously the engagement and consultation piece. So in order to get the answers to part A for all of that we've just spoken about, you need some engagement and consultation anyway, because you won't have all that information within the local authority. But part B is particularly focusing on some of the key consultees for the land and environment we've spoken about. The highways team I've mentioned a few times. Maybe neighbouring authorities. You might have a zone that actually lends itself to being across 2 authorities, and how might that work? Your heat generators, speaking to some of the identified heat opportunities we've mentioned today, energy from waste, data centre owners, existing universities, anybody who's got heat. Local DNO, so understanding what capacity is where, even at this very high level, what capacity is where, because if there's no capacity, that's a difficult one to overcome. If there's no capacity right now, we need to understand what's coming in terms of upgrades as well for the future. They may be able to say there's no capacity right now in that area, but by 2027, we will have X available. And that might be enough just to go through when you're thinking of your zones. And also local groups. At an early stage, one thing I will say I've worked on in all of my career is local groups and communities, and getting them engaged in what you're trying to achieve, rather than this just be a policy that gets enforced on people. It talks about method of engagement in the guidance, calls, emails, workshops, meetings. I would suggest, if you can, to try and do workshops, more people in one place, collaboration, etc. And it also cuts down your time if you can. But there will be need for individual calls and emails, and possibly face-to-face meetings with some of those clients. One thing I will say is, jump screen. One thing I will say is you need to keep a tracker. They give an example in the guidance of how to keep that information. We traditionally keep trackers of everybody that's involved, and the next steps, and we use that for evidence for this type of activity as well. And then part C, so when you've spoken to everybody, you've got your insights. Part C is where make a decision, and the decision of whether or not this zone should be put forward for designation. Now, I've spoken about quite a lot there, and I'm conscious of time, so I'll try and wrap this up. But what the point of the form is, it's supposed to be the insight. So it's not detailed feasibility. You don't need to go into the detail of each one of those points, which is another level. It's just the insights. So you're capturing those insights to make those decisions, and then further feasibility will be required. And then you record your decision by the drop-down box, and then you obviously, as part of the section 48, requires that you obviously have to demonstrate an area map with to go along with your decision, and then it will get published at a later stage. So they're the 3 different stages of the pro forma. This here is the next stage. So once it's been designated as a heat network zone, this is the next stage of commercialization. This is the bit where you probably need a company like ours or others that can do the detailed feasibility. Now, you might decide, actually, I'm going to give it to a heat operator. I'm going to give it to an energy services company. They're going to come and do all this. That's equally fine. But in order to understand the value of what you've got, I think this best sits with the local authority, and there's funding available through Heat Network Scotland, funding through Scottish Government that can support this feasibility, because this, at the end of that piece of work there, you would have a better understanding of what this heat network should look like, and what if the value that may be in it, because you may decide that you, as a local authority, you want to be part of it. Next slide, please. I've just attached a couple of case studies, but I won't go into them details, conscious of time. But we worked with Midlothian Council on their heat network, predominantly around the commercialisation, and we helped them in tender that as well. So obviously that's got an operator in now, which is Vattenfall. But that network there was one from an energy from waste provider. So again, there's a few different parties there that we had to negotiate the commercial arrangements. And the next one. This is Liverpool City Council. So this is a council-owned scheme. It's around the knowledge quarter. It's primarily been designed for research and education buildings, but now we're looking at how we might be able to spread that out wider to the city. This one was actually put in on a gas CHP. And so this has got a decarbonisation element to it now, where we're looking at how we might be able to decarbonise by either connecting up to other networks or looking at installing some of the heat generation sources I mentioned earlier around heat pumps, etc. Because gas CHP, as I've mentioned now, is completely out of favour. But this one was installed a few years ago on that technology. Next slide. So I've rattled through the slides. Appreciate quite quickly. There's a lot of depth I could go into on each one of those points if you wanted to, but I just want to give time now for questions and answers. But we do have a quarterly newsletter where we try and keep up to date and share with our members all our market and legislation. Feel free to sign up on the website, or if you've got any questions, my contact details are down the left-hand side of the slide there. So if we have any questions, there's opportunity to put them into the chat if you don't want to shout them out, or we can take questions from the floor as well. Is there any in the chat? I can't see the chat at the moment, so I'm not sure. Tarina, Sarah, is there any in the chat at the moment?
Not at the moment, no.
Is there any questions on anything I've said today? Did it all make perfect sense? Was it useful? Good.
Oh, Paul has his hand up. I will just unmute you, Paul.
Yeah, it's just a quick question. What's Ener-Vate's typical experience, rather, of how long it takes to typically develop a heat network?
You're not going to like the answer, but I'll give it you. Some of the schemes that we're actually putting in the ground now, we've been working on for about 3 years. And the reason that a lot of the time has been taken up is because policies like this aren't in place. So it had this policy been in place previously where there was a zone and you knew where you were going and you knew the customers because there's a lot of work done, you could speed quite a lot of that activity up. In the past, what we've had to do is knock on each door of those buildings and say, we're developing a network, would you like to connect? So you can imagine quite a considerable time has been in the early stage stakeholder engagement and feasibility. I think you could condense that down realistically, and I'm assuming that the planning permits come with that. You could condense that down to if you're wanting a network to be live, you've got at least 12 to 18 months build. So feasibility test. So I'd probably say about 2 years. You could probably condense that down. So you might be able to shave the whole year off because of the engagement piece. And the reason for that is because there's going to be mandatable buildings. There's going to be an understanding of heat network zones. There'll be some data that will be available to heat network developers that says these are the clusters and this is how much they're going to be using, albeit it all needs quantifying that we've spoken about. So I think you probably could get it down to about 2 years. And the reason I say that still is, and again, that depends on the size of the network, digging up roads, getting pipe in is still quite challenging, even with all the permits in place, because you have to work through with the road traffic acts and making sure that you can still keep the city accessible. But I would say around 2 years, if that helps.
That's great. Thank you.
No problem. Yeah, Eddie, that's absolutely fine. Thank you. We'll share that with you, the recording. And again, if anybody's got any questions after this or wants a separate discussion on this, by all means, get in touch with myself or any of the team. Any other questions?
There's just one more person typing, Jo, I think.
Okay. Thanks, Jenny. Thank you, Heather. That's great. I'm glad it's been of use. I mean, the idea of today really is to try and aid and provide that context to that form. Hopefully you're all a little bit wiser about some of the considerations that need to be made. But like I say, anybody needs anything at all, give us a shout and we can go into a little bit more detail on that. We will circulate, like I say, the slides, the recording. We'll put a copy on the website as well for future reference. But again, anybody needs anything, let us know. But thank you very much for your time today, everybody.